Good evening to everyone. This is Immanuel working as assistant professor in mechanical department of PSNA College of Engineering and Technology, Tendikal. Today I am going to talk to you about the important topic centroid or center of gravity. It is represented by the letter capital G. First we will see the definition of these two important topic. First one is centroid. It is the geometrical center where the entire area, here note the keyword area, is assumed to be concentrated. Here geometrical center where the area is assumed to be concentrated. Let me explain it with the help of your diagram. I am going to consider a area. Here it is the area. Now the area is divided into small area A1, A2, A3, A4 and up to AN, where n represents it is the number of division. And here as per this definition the entire area is assumed to be concentrated. So here the area from A1 to AN is concentrated at this geometrical center. The point G is the geometrical center. It is called as centroid, where the entire area is assumed to be concentrated. Then second important thing is you have to find the location of this centroid with respect to y-axis as well as x-axis. From y-axis it is referred by the letter x bar, and from y-axis it is referred by the letter y bar. Okay, first thing we have to find the centroid, then the location of that centroid with respect to coordinate axis. This is important. Next definition is center of gravity. Center of gravity, it is the point where the entire weight of the object is passing through. In this center of gravity, note the keyword weight. In the centroid the keyword is the area. Here the weight is passing through the center of gravity. Let me take again a weight. Okay, W is the weight. The weight is divided into small weights W1, W2, W3, W4 and Wn. Now as per the definition of center of gravity, weight of all this weight passing through a point, this is the point which we call as center of gravity. Okay, then again one more important thing, in centroid we have made an assumption, but here there is no such assumption. Here we should not assume the point as center of gravity. This is important thing. Again as usual you have to find the location of this G, center of gravity, with respect to y-axis and x-axis. It is represented by the letter x bar and here it is y bar. Then it is applicable to, this center of gravity is applicable to three-dimensional objects like prisms, pyramids we studied in engineering graphics. So we can apply into any three-dimensional objects. These are the things about the definition about centroid as well as center of gravity. The next thing is we are going to see about the reason behind why we should study centroid or center of gravity. Very important thing, the concept. Here we are going to see the concepts like rigid body and some of the things. First let me explain you that definition of rigid body. In rigid body we consider the dimension of the object, or that point dimension of the object. Okay, I can explain it with the help of a cantilever beam. This is the best example of rigid body, and in this cantilever beam there is an UDL which is acting in the over the span of 10 meter. There is an UVL which is acting over the span of 15 meter. So this is the perfect example of rigid body. And while going to solve this problem, the first step is we have to convert this UVL and UDL into point loads. So here we are going to do that. So this is the UDL. Let me take, this is the UDL. Here I have converted into point load. The value of W1 is equal to this small w1 into 10 meter. Now this point load should be located in a place. This is the place I have located, and this is referred from the distance of L1. L1. Here the L1 I call it as location. You see that this is the point we normally called as centroid. Centroid. So centroid is important thing in rigid body. Similarly, again if you convert UVL, this is the point, this is the location, this is the location which is referred from this point end, and you know that this is the L2. Here this L2 is again a location. Okay, this location indicates the position of this weight, and this is the center of gravity. So any rigid body, okay, you have to find the value of center of gravity. Moreover, we have to know one thing. This is a UDL, uniformly distributed load, and in this load, from the start to end, it consists of infinite number of forces. Infinite number of forces. So we have to find the resultant for them. Resultant for them. Then, since it is a rigid body, you have to find the location also. This is also important thing, because it has infinite number of forces. Infinite, you cannot count the forces in this UDL. The same cases like UVL also. Now to find the location in rigid body, the second unit of engineering mechanics, we have gone through an important theorem called Varignon's theorem. Varignon's theorem. This is Varignon's theorem. It says that the moment of resultant, you are referred by the letter M suffix R, is equal to the summation of the moment of individual forces. So this is what I have taken here, F1 into D1 into F2 into D2, and here up to the N, which means that the number of forces, which is equal to summation of I tends to 1 to N, Fin and dA. Now you may get a confusion, maybe why I have referred this theorem here. But you should know one thing, Varignon's theorem plays a crucial role in finding the value of the centroid or center of gravity. That I will tell you in the next video.